Okay, guys, good morning. Could you please confirm? Am I audible? All the people, please let me know my voice is clear for everyone. Could you please confirm? Okay, fine. Fine, yes, thank you. So, guys, today, without wasting the time, let me start about the particular topic. So, for that only we have came here. Okay, fine. So, today we are discussing about the one of the core topic, which is a dynamic programming, right? So first of all, guys, understand the thing. I know it's a little bit complex topic, but the thing is that once you understand the thing, you can apply this technique anywhere, right? You can apply these techniques for solving many questions, and many of the algorithms have the intuition which is related to the dynamic programming, right? We are using these techniques extensively whenever we are coding or whenever we are working on the different strategies, right? And even though if I'm talking about the machine learning, deep learning, generative AI, so most of the algorithms and most of the techniques in this area uses the DP extensively, right? Sometimes the dynamic programmings are getting used implicitly and sometimes it is getting used explicitly, right? We'll see the various use cases of the DP in the area of machine learning, deep learning, and Gen AI as well, right? Because today I'm discussing about the basics, okay, how exactly the DP will work, what will be the memoization, what will be the tabulation techniques, and everything. And later we'll, in the particularly in the tomorrow's session, we'll code the neural network by using DP, right? Right, so we'll code the forward propagation and backward propagation of the neural network from the scratch by using the dynamic programming. So my intuition is what, guys, please try to understand the concept, okay, try to apply the things, right? We'll take some sort of problem statement, and in the next session probably we'll try to code the neural network by using dynamic programming. So that's the reason it's not that much complex, but you understand, you grab the things, you can easily code it, right? So fine. So without wasting the time, guys, let me start about the what is dynamic programming and how it is applicable everywhere. Okay, fine. So guys, I already told you that you don't have to know much thing except one prerequisite, right? One prerequisite, right? Which is a recursion. Right. So the most important thing about the DP that at least you should know the recursion. Okay. I'm just quickly revising, guys, because completing the recursion will itself take 2 hours of time, right? So I'm just brush upping the things because most of the people you aware of the recursion and most of the people who heard about the DP, they know that, okay, that we required a recursion, particularly in the case of DP, right? Fine. So fine, so we'll start, guys, okay, all this thing. And what is the agenda? Today's agenda, if I'm talking, that first of all we'll start with the basics. Just I'm giving just 5 minutes of overview, 5 minutes of overview about the recursion, right? I'm not telling you that you have to know many more techniques, but at least you know the recursion, right? Second thing, we'll discuss what is dynamic programming. See, guys, let me not make this topic very complicated because most of the people are beginners. So I'm not directly moving into the ML use case where exactly we are using the DP, or we are not directly start coding the neural network here, right, with the help of DP. So that's the reason I'm keeping this webinar very simple so that everybody should understand, right? And those people who not aware too much about the recursion, at least I'm hoping that they know the functions, how to write a function, how the function call, we are calling the function, and remaining things, right? Fine. So what is dynamic programming, we'll discuss, and we'll take one problem statement, we'll take one problem statement, right? And then we'll differentiate dynamic programming, dynamic programming versus divide and conquer, divide and conquer techniques. I will also explain you guys, because although most of the people, not people, will think that okay, this is the completely DSA kind of stuff. I will tell the every use case where exactly we are using the divide and conquer. I will tell the one of the algorithms there in the machine learning, which is a support vector machine. And I will tell you how we are making the intuition with the help of divide and conquer techniques for the support vector machine, right? So that you will understand the beauty of this dynamic programming and the beauty of data structures. Okay. And we'll see how exactly that in this, particularly we are talking about the machine learning, data science, and deep learning kinds of stuff. I will tell you each and every case where exactly you are implicitly or explicitly using the data structures, right? Particularly in the AI domain, right? Right? Because without data structure, there is no industry, guys. Listen, fine. So we will see the dynamic programming and divide and conquer strategy, and then how to apply DP and when to apply. When to apply DP, correct? Fine. And then finally, we'll take some of the lead code question, right? Some lead code. So this is the today agenda, guys. Let's see what will happen. And then probably in the tomorrows, we'll understand the neural network and we'll try to code the neural network from the scratch with the help of recursion and DP. Correct? Fine. Okay, fine. So I hope guys up to here clear, everyone. Right. So let me start, guys. What is DP? Okay. So dynamic programming, what is, see, I'm not making this much too theoretical, guys. So that's why we'll discuss only just brush upping the things and directly we are moving on to the code. So what is DP, right? So guys, I already told that we required a prerequisite, which is a recursion. And those who don't know the recursion, guys, at least they know how to write a function in Python, right? So we are going to code everything in Python. So I'm hoping that everyone should aware of the Python. Okay. So guys, without wasting a time, we know that recursion means what? A function calling itself, a function calling itself again and again and again, until some condition will get satisfied, until some condition will get satisfied, right? So particularly, guys, we know that whenever we have a problem statement, right, and which is a repetitive kind of problem statement, right, repetitive problem statement, we generally have a two approaches. One is iterative approach, and the second one is the recursive approach, correct? So whenever we have a problem statement, which is a repetitive kind of problem statement, so we have only two kinds of approaches to solve that problem. One is iterative approach and another way is recursive approach. So guys, these are the approaches generally we are using everywhere, right? If you talk about the any domain, so generally we are talking about these two approaches only, right? I will tell, will differentiate at the last what are the iterative algorithms in machine learning, deep learning, and also what are the recursive approach in the ML and DL, right? Fine. So these are the two approaches, and we know that suppose you wanted to write any code using recursion, we need to find out two steps, right? We need to find out two steps whenever we are writing any code in recursion, correct? So the first step is we need to find out the anchor step, right? We need to find out the anchor step. And the second step is what? We need to find out the recursive step, or we can say that it's an inductive step, recursive steps. And we already discussed, guys, this thing that anchor step is nothing but the stop step, or we can call it as the base condition where exactly we need to stop, right? So in the same way, guys, if you're writing any code using loops, so we are always keeping the termination condition there. So termination condition will specify us where exactly you need to stop the loop. Same thing, recursion means we are calling the same function again and again, but up to where you need to call or where exactly you need to stop calling the function, that will be decided by the anchor step or stop step, right? And the second condition is what? Recursive step is nothing but the repetitive step. Repetitive step means what? I know that we are calling the same function again and again. So particularly in the case of recursion, all the repetitive steps will be the function call only, right? So we understood one thing, guys, that recursion is nothing but we are calling the same function again and again until some condition will get satisfied. And we are using this approach particularly whenever we have a repetitive kind of the problem statement. So we always need to find, is there any kind of repetition given in the problem statement? In that case, we are going to use the recursion, right? And to write down the code in the recursion, we have a two steps. We have an anchor step and we have a recursive step. Anchor step stands for where exactly you are stopping, and recursive step is nothing but a repetitive step. In that particularly the recursive call or the function call will come. Correct? Fine. So let's take a simple example, guys, so that you can understand the things in a better way. What exactly? So without wasting a time, I will take a simple example of suppose let's take Fibonacci. So let me the nth Fibonacci number, right? Suppose I need to find out the nth Fibonacci number, and most of the people aware of what exactly the Fibonacci number, right? So guys, generally suppose I'm talking about what is the 0th Fibonacci number, right? So 0th Fibonacci number is nothing but the 0. Suppose I'm talking about the first Fibonacci number, right? So the first Fibonacci number is a what? First Fibonacci number is 1. If I'm talking about the second Fibonacci number, right? Second Fibonacci number. Second Fibonacci number means what? You add this two, right? So first Fibonacci number and 0th Fibonacci number. If you add this two number, you will get the second Fibonacci number, which is 1. Suppose I want the third Fibonacci number. So then you add the first one and second one, you will get the third Fibonacci number, which is 2. Correct? Similarly, suppose I want the fourth Fibonacci number. So you add this two, means this previous one and this second one. Simple logic, guys. So suppose I want a fourth Fibonacci number, means you need to add the third Fibonacci number and second Fibonacci number. So particularly fourth Fibonacci number is nothing but the 3. Correct? So this is the logic generally to find out the Fibonacci number, right? And suppose, guys, generally we know that the first Fibonacci number and the 0th Fibonacci number is particularly the base case for us. So suppose I'm telling that I wanted to find out the nth Fibonacci number, and suppose I'm writing f of 0, means I'm talking about the 0th Fibonacci number is nothing but the 0. Suppose I'm talking about the first Fibonacci number, the value will be 1. Correct? I hope, guys, most of the people up to here is clear, right? That this is the 0th Fibonacci number and this is the first Fibonacci number. Correct? Fine. Now the question is, guys, suppose we need to find out the nth Fibonacci number, correct? So if you think about this particular problem statement, these are the initial step, right? Where exactly this value we have to know, right? What is the 0th Fibonacci number and what is the first Fibonacci number? If you know this two value, then only we'll able to find out this second Fibonacci number value, correct? So if you know the value of first and second, then only you will able to find out the third Fibonacci number value, correct? So suppose I wanted to write a simple recursive code for this one. So the code will be like this, that we are writing def. I hope everyone know how to write a code in Python. So I'm writing def fibo. I'm passing here n, correct? And let me write down if n is less than or equals to 1, then particularly I will return n, and else if this is not a case, then I will write here return fibo of n minus 1 plus fibo of n minus 2. Generally, this is the kind of code we are writing whenever we are finding out the nth Fibonacci number. And if you observe this one, guys, this is nothing but a recursive code, right? Why it's a recursive code? Yes, why it is a recursive code, guys? Because we know that this is the function and we are calling the same function again and again until the particular condition is getting satisfied. As I told you that whenever you are writing a recursive code, you need to find out the two steps. So the first step is base step or anchor step and second step is recursive step. So this is what? This is your anchor step, right? Where exactly you need to stop calling the function. And if you're talking about this one, this is your recursive step. This is your recursive step, means you are repeatedly executing these steps up to the function will not get or up to the condition will not get satisfied. Correct? So this is the simple recursive code for that one. Okay. Now we'll understand, guys. We are moving towards the DP only, but we'll understand Okay, what exactly the DP and how exactly the DP will work, right? So this is the general. Up to here everyone know that how to write a recursive code particularly, right? Please understand guys, this simple question will make a huge difference. You will understand the intuition because we have to code the neural network by using DP, correct? So we are using this recursive approach to code the neural network using DP. Fine. So now listen, suppose I'm asking you one simple question for this one, guys. What is the time complexity of this one? What is the time complexity of this code? What is the time complexity as well as what is the space complexity? What is the space complexity? Right. So what is the time complexity and what is the space complexity of this code? Anyone knows, guys? Right? Right, fine. So no, it's not the order of n square. Right, fine. Correct, fine. And so guys, this is the kind of pseudo code. So I'm not calling this. We know that we need to call. Everyone know that we need to call this function, right? Fine. So it's a 2 power n, order of 2 power n. Correct. Fine. So if you're trying to find out the time complexity, it will be order of 2 power n. Correct. And if I'm talking about the space complexity here, space complexity will be order of. Just come on, guys, because we know that this is the recursive steps. So we know that stack is getting created. Stack is getting created. Stack is getting created implicitly, right? So automatically, whenever we are writing any recursive code, so stack is getting created implicitly, correct? So we know that in this case, the space complexity will be order of n, correct? Fine. So guys, suppose if you see here and if you consider this time complexity into the consideration, we know that this is nothing but the exponential time. This is nothing but the exponential time, correct? And in particularly in the area of computer science, exponential time will be the huge time, correct? Fine. So how will able to reduce this time? Even though guys, if you see the question number 509, right? Particularly if you see the lead code question 509, this is the nth Fibonacci number question only, right? So lead code 509. If you try to code this question using this approach, using this approach, particularly if you will find out that it is taking more time, right? Right, because initially, suppose guys, if n value is 5, let's take n value equals to 5, right? So suppose I'm asking you the question, how many times or how many number of functions call should be there if n value is getting 5? Simple question, guys. How many function calls? How many function calls will be there, right? If we have n equals to 5. Any answer, guys? If I'm telling that how many function calls will be there if n equals to 5? 4, 32, correct? 32 is the correct answer, guys, that we require the 32 function calls. Okay. Those who don't understand why 32, let's see it. See. Suppose let me take a simple example, guys. Let's take the same value that f of 5, right? So we know that f of 5, this is my f of 5, correct? And we know that n is greater than 1, right? Means n is not equals to 0 or n is not equals to 1. So this is not anchor set. So I'm telling that there is a function call for f of 4 and there is a function call for f of 2, correct? Sorry, f of 3. So if you see that this is the one function call and this is the one function call and we have a plus here, correct? So for f to get the value of f of 5, we need to add f of 4 and we need to add f of 3. Similarly, to get the value of f of 4, we need to add f of 3, right? Plus we need to add f of 2, correct? Similarly, if you wanted to find the value of f of 3, so you need to find out the value of f of 2 plus f of 1. Correct. These are the general values, guys. Correct. And we know that f of 0, if you are trying to find out the value for f of 0 is 0 and f of 1 value is 1. So we make this as the base condition, right? Because these are the initial values of the Fibonacci, right? And if you see here, guys, if you see here, right, this is nothing but you are getting one kind of binary tree here, right? And if you are trying to find out the number of function call, because in the case of recursion, the time complexity is decided by the number of function calls. So here you have a function call one, right? This is the two function calls. If you talk about this one, f of 3 is nothing but what, guys? F of 2 plus f of 1, correct? So if I'm talking about the number of function call will be 4 here, right? If you go here you will get number of function call should be 8, like that and so on, correct? So initially, guys, if you're talking about this is the first level, right? Suppose I'm giving here level 0 binary tree. This is my level 1, level 2 and level 3, right? These are the tree. And if I'm trying to calculate the number of function call, here the number of function call will be 1, here the number of function call will be 2, here the number of function call will be 4, and here the number of function call will be 8, right? So if I'm writing it in this way, this 2 power 0, just to make it simple, 2 power 1, here is 2 power 2, right? And this is the 2 power 3, like that, so on, right? So it will give the function in the form of 2 power n. So I can directly say that the time complexity in this case will be 2 power n. Simple, right? Correct? Fine. Now the question is, guys, okay, can we reduce this time? Can we reduce? Right? The question is that here you are getting the time complexity as 2 power n. Our question is what? Can we reduce this time? Right? So I wanted to reduce this exponential time. So can we reduce this time? Right? So we can reduce this time, guys. We can reduce with the help of DP, right? Which is nothing but the dynamic programming, right? So guys, if those people who are particularly solving the lead code kind of stuffs, they know that particularly they are trying to submit the recursive approach in the lead code. They are always telling that the time limit exceed, or second thing is what, the memory is full. This kind of particular issue they are getting, right? So guys, DP, if I'm talking about the DP is nothing but what? It is nothing but the optimization of your recursion, right? So dynamic programming is mainly over the, so suppose I'm talking about the dynamic programming is an mainly the optimization over recursion, right? Dynamic programming is a mainly optimization over the recursion. So particularly what is the approach we are going to follow here, guys? We are first to write the code using recursion, and then we are trying to optimize with the help of DP concepts, right? So first of all, understand the intuition where exactly we can reduce the time, right? So if you see about this particular question here, guys, we know that this is the function 5, this is the function of 4, function of 3, right? If you observe this one, here we are calculating the function f of 3, guys, correct? Here also we are calculating the function f of 3, and here also we are calculating the function f of 3. So if you are observing, guys, f of 3 here also we are calculating, and f of 3 here also we are calculating, right? So if you observe this one, for this function we have a same kind of input, right? Here also 3, and here also you have a 3. We have a same kind of input, correct? Fine. So what we are trying to say here, suppose we wanted to reduce the time complexity for this one, so we need to stop calling the same function again and again unnecessary, because here also we are calculating the value of f of 3, here also we are calculating the value of f of 3, here also we are calculating the value of f of 2, here also we are calculating the value of f of 2, here also even though. So if you are talking about the f of 5, guys, indirectly f of 3 we are calling 2 times, right? And if I'm talking about the f of 2, right, f of 2 you are calling 3 times, right? F of 2 you are calling 3 times, and even though f of 1 also you are calling multiple times, right? So guys, we know that if I'm talking about the If I'm talking about the recursive approach, right? And if I wanted to calculate the time complexity for the recursive approach, time complexity for a recursive code, time complexity for a recursive code is nothing but the number of function calls, correct? Time complexity of the recursive code is number of function calls, correct? Now, if I somehow able to reduce the number of function call, guys, automatically the time complexity is getting reduced. Yes or no? Right? So, guys, what is the intuition behind the this one? Right? What is the intuition behind this one, guys? That somehow, if you are able to reduce the number of function calls here, right? Automatically, the time complexity of this recursive code will be reduced, right? This is the core intuition of the dynamic programming, right? So, what we need to do, we have to stop calling the same function again and again. Means what I'm trying to say, once you have calculated this f of 3, you store the value of this f of 3, right? Once you have calculated the f of 3, you store the value of this f of 3 so that you are not recomputing it again, right? So once you store the value of this f of 3, you stored it in the memory, right? Suppose this is the f of 3. I'm storing the f of 3 value so that next time the f of 3 will come, I don't need to recompute this value, right? I will simply go into the memory. I will see what is the value of f of 3 and I will add it. So what is the advantage of that? You don't need to call this function again, right? That is the beauty of TP, right? So what we have to do, we have to stop calling the same function again and again. So whatever the result we are getting from the each function, we are trying to store the value of that function so that at the time of recomputation we can directly use the value. You don't need to call a particular function. So this is the core idea behind the dynamic programming, right? So what I'm trying to say, guys, this is generally we need to stop calling same function again and again. We need to stop calling the same function again and again. So once you got the solution for a particular function, so you stored the solution, the stored the solution for each function, in memory, each function in memory, right? So this is the general approach we are following so that the number of function call is getting reduced automatically, right? So this is the core intuition of the DP. Although guys, I hope you understand what exactly we are trying to do here. We are just simply trying to avoid the same function call calling again and again. That's the whole idea behind this one. Because rather than solving the same function again and again, we are thinking that we'll try to store the result of that function call in the memory so that once the same function call will come, we can directly take the value from the memory. So we don't need to do the recomputation. And because of that, the number of function call is getting reduced and automatically the time complexity of this program is getting reduced. Okay. So guys, we'll code it. Okay. We'll code it. But first of all, understand how exactly we are writing the solution for this one. Correct. So if I'm talking about in the general sense, if I'm talking about in the general sense, let me code this one, guys, first. Okay, fine. And then we'll slowly understand what is the approaches and what is the method, particularly in the case of DP. Again, I'm telling guys one thing. I'm writing the recursive code, right? So make sure that you know the recursion and you will able to write the recursive code, correct? Otherwise, what will happen? Whatever I'm going to teach or whatever I'm teaching, you will not understand it properly, right? So that's the main reason I'm telling here. Please try to understand the recursion. And if you don't know, please guys, just brush up the things. Then only the DP will be easy for you, right? Up to here, clear, guys? So guys, recording you will get, this will be, although this will be available in the YouTube now, so you will get a recording. See guys, don't worry about the recording, please focus, because my intention is what? That tomorrow we need to code the neural network, so please understand same approach we are going to use, right? Fine. So let me code first of all in the recursive way, right? Then we'll move Then we'll try to use the DP, right? So suppose, for example, same code I'm writing, and after this we'll do the one of the lead code question, guys. Right. So first of all, see guys, rather than keeping too much theoretical things, it's better that we'll code it, right? So I'm writing here if n is less than or equals to 1. This is the base case. I'll simply written, right? If this is not a scenario, if this is not a scenario, I will simply written Fibo of n minus 1 plus Fibo of n minus 2. Correct? This is the case. And suppose let me call for the Fibo of 5. Right? So guys, this is the fifth Fibonacci number that we are directly getting here. But we know that if I'm trying to find out the time complexity, this one is what? Order of 2 power n, which is exponential. And the space complexity in this case is what? The space complexity in this case is what? Order of n, because the stack is getting created implicitly. Correct? Fine. Now, same code I wanted to write using DP, but to understand the DP, that what exactly we need to do, where we are calling the same function again and again, we need to stop calling it. And once I got, suppose we know that here f of 3, we know the f of 3 value. Once we have computed this f of 3 value, we have to store that value, right? So that we can use this value later, right? This is the strategy that we are following in the DP, right? See guys, although we have a two methods in the dynamic programming, one is tabulation and memoization, but I let me not make you confuse, right, by explaining different. But the thing is that this is the general approach of the DP, that whatever the result we are getting from the each function, we are trying to store it. Okay, now listen. Before coding it, first of all, understand guys, in which case and which scenario we are going to use the DP, right? So when to use DP. See guys, this is the trick. These are the some tricks which I made particularly to solve a DP question, right? So generally what happen guys, first of all, people are getting issue that whether it is a recursive question or not, right? So finding out the question is a DP question is a little bit tough, right? So first of all, understand how we will recognize that it's a DP question, right? So first of all, guys, if you observe this question, if you observe this problem statement, suppose I wanted to find out the value for f of 5, right? Suppose I wanted to find out the value for f of 5. We need to know that we have to check for all possible values, right? We have to check for all possible value. For example, I have n equals to 5, correct? But to get the value of 5, I have to find out the value of 4. I have to find out the value of 3. I have to find out the value of 2. I have to find out the value of 1. And I have to find out the value of 0, right? So what I'm trying to say, when you will use the DP, when you have to check all the possibilities, guys, right? That's the reason they are telling that DP is the best approach, because whatever the possibilities you have, we are trying to see all the possibility, and after seeing all the possibility, we are trying to find out the best among all the possibilities. That is nothing but the DP, right? So those who know one thing, we have very two good approaches particularly, right? One approach is a greedy, right? Those who know greedy. So one is greedy approach, right? And another one is, this is DP, right? So this two approaches are somewhat similar, guys. Intuitively somewhat similar, right? So greedy means what? If I'm talking about the Hindi word, greedy means lalchi, right? So greedy is what? Suppose I have to choose, suppose let's take the example, guys. Suppose I have to choose, I have to buy a car, right? And we suppose I wanted to select which car is best, and to select the best car, we have supposed to approach. One is greedy approach and one is DP approach. So greedy approach means what, guys? Currently at this moment, what is the best possible thing for me? Best possible thing for me, right? Currently, at this moment, what is the best possible thing for me? That is nothing but the greedy approach, right? So what I'm saying that, okay, currently this car is trending. This is in my budget. I will directly, okay, this is the fine choice for me. I will directly select it, right? That is nothing but the greedy approach, right? That is nothing but a greedy approach. Guys, particularly in the ML also, we have so many greedy algorithms, right? So many greedy algorithms, right? And we also have the DP based algorithm, right? Generally, whenever we have a recursive approach, particularly in the case of machine learning and deep learning, so wherever we are using the recursion, definitely we can use the DP to reduce the time, right? You take any example, guys, particularly in the reinforcement learning, we have a hidden Markov model, right? That is also the recursive approach. We are using the DP extensively to reduce the number of function call in that case also. Even though if you take the example of neural network, we have a backward propagation. You take the example of recurrent neural network also, guys, because which is a sequence model where exactly we need to store the result of the previous tokens, right? In that case also, even though transformers also, guys, you are going to use the dynamic programming strategy implicitly there, not explicitly but implicitly, right? Fine. If you take about the generative example, we have a BIM search and all this kind of algorithms that they are internally using the DP techniques, right? Fine. So this is the simple question that, okay, we need to buy a car, and I greedy approach means what? Currently at this moment, what is the best possible thing for me? That the thing I will choose, correct? But in the case of DP means what I will do, guys? I will see, we will see we will see all the possible all the possible searches for a car, all the possible searches for a car, right? So in the DP we'll see all the possible searches for a car, and after searching all the cars we'll search the best of that, which will seek the best of that. For example, guys, suppose my example is that we need to buy a car, correct? Suppose I wanted to buy a car. So what I need to do? I need to do, I will find out all the possible cars, right? Different companies, different prices and all these things. And among all that possibilities, I will trying to choose the best one, right? That is my DP approach generally. So if you observe this one, guys, greedy will tell that at this moment, whichever is the best thing for me, that I will choose. In the DP, they are telling that no, we are not only seeing at this moment, see all the possible cars in my budget. Among that, which one is the best for me, that I will select, right? Same thing, guys, same strategy we are using here. When to use DP? First thing is what, or first the hint is what? Whenever you need to check the all the possibilities, guys, right? So whenever you need to check the all the possibility, particularly in that case, we are using DP. I will tell you guys where the divide and conquer, DP and greedy is fit. Don't worry, right? So I'm telling that just wait, guys. We'll talk about the divide and conquer also, and we'll see one of the intuition of the ML and the divide and conquer. Fine. So see what I'm trying to say. Greedy means what? At this moment, which is the best thing for me, I will go for the greedy. And DP is means, or I will see all the possible things, and among that which one is the best for me, that I will select, correct? Fine. Second thing is what, guys? This is the first way to select the DP problem statement. Second way is what? If you observe our case, guys, or if you observe our case, whenever you have this kind of scenario, generally, guys, this is our sub problem, because our main problem is what? We need to find out the f of 5, right? But we have one sub problem which is f of 3, and here also we have a one sub problem, our f of 3, right? So this problem, generally we call it as the overlapping sub problem. Overlapping sub problem means what, guys? For a same kind of input, you are calling the same function, right? Simple. Here also you are calling the f of 3. Here also you are calling the f of 3. You have a same input here, which is a 3, right? So this kind of problem, generally we call it as the overlapping sub problem, right? Same problem. This is your sub problem, and this is also your sub problem, right? And it is calling for the same input, which is a 3, right? So this we call it as the overlapping sub problem. We call it as the overlapping sub problem, right? So the first step is to identify that you need to check out for the all the possible values. This is the first way, right? That we are going to see all the possibilities to find out the particular things. Second thing is what? If there is a overlapping sub problem, right? Overlapping sub problem means what, guys? You have a see, guys, this is your main problem and this is your sub problem, correct? Now, if you see this problem, right, you have a same kind of input for this both problem, which is f of 3 and f of 3, right? So this kind of problem generally we call it as the overlapping sub problem, and this is the criteria to identify that it's a DP problem, right? Sometimes what happen, guys, we are having the overlapping sub problem in the case of divide and conquer also, right? Right, we'll see what is the difference between divide and conquer and DP. But here I'm just telling how to identify it's a DP problem. First thing is what, you need to check all the possibility, and second thing is what, overlapping sub problem. Third thing is what, the people who are daily doing lead code, they got to know that this is the third strategy, that if we have any problem, we have any problem, if we have any problem, and first of all, what you will do, guys, if you have any problem, we apply, suppose we assume that okay, this is the kind of problem statement, right, where exactly we need to maximize or minimize thing. I'm talking about the optimization problem. I'm talking about the optimization problem. Optimization problem is what, guys, where we need to maximize or minimize something, right? Where we need to maximize or minimize something, that kind of problem, we call it as optimization problem. Particularly in the case of everywhere, guys, we need to something maximize or minimize. Let's take the example of regression, right, which is one of the ML algorithm. Here we need to minimize the error, right? So residual error we need to minimize. So this is nothing but the optimization problem, right? Particularly if you take the example of the SVM, right? There we have a hinge loss, right? So we need to minimize that loss, right? And we need to maximize the margin distance, right? That is that kind of problem statement. We call it as the optimization problem statement, where we have to maximize something or we have to minimize something, right? So what we need to do is here, I'm telling that suppose we have any problem statement, what we'll do, we will try to solve that problem using greedy first, greedy first, right? If if that problem is not giving proper solution using greedy, then what we will do, guys, then we will see first step, is that a recursive problem, is that a recursive problem, right? Okay, if it is a recursive problem, then you check the step number 1 and step number 2, right? So you will check this step 1 and, right, means what, first of all, guys, simple. You will take a problem statement, you will see that we'll try to solve that problem by using greedy approach. Okay, if the greedy is not giving the proper solution here, if the greedy is not giving the proper solution here, you will check that, is that a recursive problem? Okay, if it is a recursive problem, then I will check that, okay, is there any kind of overlapping sub problem, or we need to check for all the possibilities here. If this is the scenario, then definitely that problem is getting solved using TP. Correct? So there are three ways, guys, to identify this. Okay, I know that most of the people don't know the greedy, but guys, for some time, अभी के लिए आप इतना समझ लीजिए कि okay, that we have that kind of scenario where the problem is not getting solved using greedy. Definitely, we are using the DP. But to identify this one, guys, in a general sense, for now you understand this two thing, that okay, if we need to find out all the possibility, we can use the DP. Second thing is what, if there is any kind of overlapping sub problem, we will use the DP. Okay, up to here clear, guys, everyone? I'm asking, yes or no? Yes or no, guys? I just wanted to know because I want everyone to understand the things. Fine. Fine. Please understand, guys, otherwise tomorrow's session you won't understand. Again, I'm telling, right? So if you have any kind of doubt, please ask. I don't have any issue in between us. Right. Now see. So what we'll do, guys, here now. We know that one thing, we understand, okay, we identify. I will show you how to identify the things with the help of whatever the hints we have discussed. So before that, guys, before that, let me talk about one of the guy asked the question, what is the difference between divide and conquer and DP? So let me talk about DP stands for dynamic programming. We already discussed, and we have a divide and conquer strategy. Right? I hope, guys, most of the people know what is a divide and conquer strategy. Divide and conquer strategy. Strategy. Right. So as DP, you already know what is a DP, right? That it is nothing but the optimization over the recursion. And divide and conquer strategy, guys. Yes, anyone know divide and conquer strategy, guys? Let me know. Anyone? So if I'm talking about the divide and conquer means we are dividing the larger problem into the smaller problem, correct? Right. So I'm telling that we know that we are dividing a big problem into small problems. So we are dividing the big problem, into small problem. Right? Correct. This is nothing but the divide and conquer strategy. We are telling that every problem is a big, and we are trying to divide the problem into the small problem. In a DP also, we are doing the same thing, guys. If you observe properly DP, let's take this example. Right. So earlier we need to find out the solution for f of 5. Right. And we are thinking that, okay, this is the big solution or big problem statement. We are trying to divide into the small problem, which is f of 4. Here also we are trying to divide it into small problem, which is f of 3. Again, we are considering this problem as a big problem, which is f of 4. Again, we are trying to divide into f of 3 and f of 2. Right. So ultimately, the dynamic programming also doing the same thing. That what? We are trying to divide a problem, larger problem into the small problem. Second thing, guys, DP is also a recursive approach. DP is also a recursive approach. And divide and conquer is also a recursive approach. Divide and conquer is also a recursive approach. Correct? See, guys, same thing both are, but the one thing about the divide and conquer and DP is what? Divide and conquer, you can say that it's a subset of DP, right? Or you can say that DP is an extension to the divide and conquer, right? For just a sake of information, guys, please understand this thing, okay? Because this is not a divide and conquer session, so that I will explain you entire thing. But in the future, definitely we are trying to cover all the algorithm techniques. But understand one thing, that DP also, what is the approach? That we are trying to divide the bigger problem into smaller problem. Similarly, divide and conquer also, we are trying to divide the bigger problem into the smaller problem. And one more thing, that divide and conquer is a subset of DP, and DP is an extension to the divide and conquer, right? So simple thing, guys. Okay, if I'm talking about the thing, both are the recursive approach, means both are using the stack. Okay, and which is a less efficient, which is a more efficient, that we'll discuss. But for a sake of information, इतना आप समझ लीजिए कि that okay, these are the similar kind of algorithmic strategies, but divide and conquer is a subset of DP, and DP is an extension to the divide and conquer strategy, right? Ah, guys, I will tell now how I'll differentiate. Don't worry. How to differentiate the divide and conquer and how to differentiate this one, right? So don't worry. First of all, understand the things, whatever I'm telling. I will tell you how to differentiate the things. Okay, fine. So simple, guys. Suppose let's take the simple example of divide and conquer techniques. Correct. First of all, suppose I wanted to sort a list. Right. Let's take suppose I wanted to sort a particular list. Okay. Now what I will do, guys, if I wanted to sort a particular list. Okay. So general thing is what? We are using the bubble sort, that we are comparing the element with each other and we are trying to sort. So assume that this is my list. Correct. This is my list. And what I will do? What I will do here? I will try to divide. I'm considering this problem as a large problem. I'm considering this problem as a large problem or bigger problem. So what is the strategy for divide and conquer? Divide and conquer will tell us that you need to divide this problem into the small problem. So this is what suppose this is my small problem. This one is a small problem and this one is also a small problem. Okay. So this is my small problem, right? Correct. Now I'm telling that, okay, this is the small problem and this is the small problem. Okay. If it is a small problem, you directly find out the solution for the small problem. Now, suppose I'm assuming that this problem is also big, I will further divide. I will further divide it. This is also and this is also. Correct. So up to when you are dividing, guys, up to that it will become a small problem. Up to that we need to divide it, right? So continuously you have to divide. Up to that it will become a small one. For example, suppose I have only one element present in the list. This is my small problem get. It is already sorted. So if you have only two element present in the list, in a one comparison, I will get an answer. This is also the small problem. So up to it will become a small problem. We are continuously dividing it. The main criteria for the divide and conquer is what, guys? My large problem is a sort problem. My large problem is a sort problem, and whatever the smaller problem I am creating, it must be a sort problem, right? It's not like that the bigger problem is a sort problem and the smaller problem is a search problem, right? So if that is a scenario, we cannot apply a divide and conquer strategy. We can't apply divide and conquer strategy, right? But if you observe this one, guys, if you observe this one, particularly in the case of divide and conquer strategy, in the case of divide and conquer strategy, let's if I do the extension to the particular problem also, this is suppose this problem will contains n values, correct? Now whenever you are dividing that problem into two parts, you got a two sub problems, correct? So this is your main problem and this is your sub problem 1 and this is your sub problem 2. You got here two sub problems, correct? Now, if it is a small problem, you are directly find out the solution, guys. If you observe this one, this is the sub problem different and this is the sub problem different, correct? Right? And but the thing is that this is also sorting problem and this is also sorting problem that we can use the divide and conquer strategy. Now, see guys, compare our problem. You have a f of 5, correct? And you here you have a f of 4 and here you have a f of 3, correct? You have a f of 3 here, correct? And if I go further, you have what here? You have here f of 3 and here you have a f of 2, correct? And we know that suppose if I'm considering this problem, this is also recursive approach and this is also recursive approach, correct? But here if you observe guys, here the sub problems are overlapping, right? Here the sub problems are overlapping, right? But in this case, I cannot say that, okay, we have sorted this one already, so you don't need to sort this one. Right? See, there might be a scenario that one of the array is already sorted. If I'm taking this half portion, there might be a scenario that this is already sorted, so you don't need to do anything. But mostly in the case of divide and conquer strategy, you will rarely have a chance that you will get the overlapping subproblems, right? But in the case of the problem which is getting solved using dynamic programming, definitely you will get the overlapping subproblem, guys. Right? This is the key to identify which problem is a divide and conquer strategy and which problem is a DP. Right? Particularly, see guys, if you see any problem statement, sometimes you feel that, sir, this is the kind of divide and conquer also we can solve. This is the problem where we can solve using DP. But the main thing is what you need to identify by making this kind of scenario, that is there really any kind of overlapping sub problem, right? So definitely if this, is there any kind of overlapping sub problem, then definitely we are going to use DP, right? Otherwise you can simply use the divide and conquer strategy. This is also the recursive approach, correct? I hope guys up to here clear, yes or no? Again I'm telling guys, focus. Clear, yes or no? Fine, thank you. Now guys, listen. see guys, we are learning the AI, data science, and all this kind of thing. Whatever the techniques I'm telling that this all are very useful if you learn the things properly, right? Because again, I'm telling these are the core things, guys. This algorithmic techniques and all this thing. And if I'm talking about the data science and AI, what exactly we are learning algorithms only, guys. If you don't know the algorithm properly, you will not able to work properly. Again, I'm telling it's not like that simply importing and exporting you create a machine learning model, right? That 10th class student can also do. He can also create the machine learning and deep learning model. But if you don't know the intuition, it's a completely waste of time to learn the machine learning, deep learning, and Gen AI by simply using the things. Because we are not only the person who are using the AI, we are the developer. So we have to know how the things is built exactly and how we are going to build it. Right? Fine. So let me take the simple example, guys, where exactly we can use the divide and conquer because we have a SVM, right? SVM is one of the algorithms in the machine learning, right? We generally call it as the classification algorithm, right? Classification algorithm, right? Those who don't know the classification, don't worry, guys. Just listen now, right? So I'm telling that SVM is one of the classification algorithm, and for a simple sake of simple example, guys, what we are trying to do. Suppose I have one kind of problem statement where exactly you need to predict, right? Suppose you have a data. Just explaining guys how divide and conquer is useful and what are the application of a divide and conquer, particularly in the case of machine learning, right? So please understand the things. Again, we'll discuss all these things whenever the particular machine learning topic will come, right? So what I'm trying to say, we are seeing the SVM intuition using divide and conquer. Using divide and conquer, right? Listen guys, bada sa simple sa hai, right? Listen, just we are saying the intuition, right? Listen, now I'm telling that suppose guys I have a data, right? I have a data, right? And on the basis of data, suppose I have created one model, right? And that what the model will predict that the person is a diabetic or person is a non-diabetic. Person is a non-diabetic. Person is a diabetic or person is a non-diabetic. So guys, here we are predicting the categories, right? Whenever we are predicting the categories, in a simple word, whenever we are predicting the category, right, we generally call it as the classification problem. In a simple word, this is nothing but a classification problem that we are predicting about the particular class, that okay, this person is belong to the diabetic class and this person is not belong to the diabetic class. So we are predicting that okay, this is a diabetic and this is a non-diabetic, correct? So this kind of problem statement we generally call it as the classification problem statement. Okay, now fine guys, suppose I have a data and how exactly we are going to classify the data. Listen, so suppose assume that this is, let me take the two-dimensional space here. You have a x-axis and you have a y-axis, correct? You have a x-axis and you have a y-axis here, fine. Now what we are trying to do guys, suppose whatever the data I have, suppose I'm telling that this star will represent the person is having the diabetic and this, suppose this circle will represent the person is a non-diabetic, just for information guys, so that you will understand the things. Okay, fine. So what I need to do, I'm telling that okay, we are doing the classification. So some points are here, right? Suppose these are the points are coming onto the graph. This is the star, this is the star, right? This is the star, right? And each star is representing that this point is belong to the diabetic class, correct? Like this. And here also suppose you have, sorry guys, here also suppose you have a points like this, right? Assume that, right? These are the point belong to the, these are the point belong to the non-diabetic class like this, correct? Fine. Now guys, listen. Now what I need to do, suppose any different point will come. Suppose this is the XQ point, right? Right. This is the XQ point will come, right? Now I need to predict for this point. This point is nothing but any patient guys, right? And I need to predict for this patient that, okay, this patient is a diabetic or not. What I will do guys, I will draw a one line. We generally call it as the hyperplane, right? Or we can say that marginal plane, right? So I'm drawing this line here and I will see that this is my XQ point and I'm telling that I know that this is my region which is belong to the diabetic and this is my region will belong to the non-diabetic, correct? Simple. And I'm seeing that, okay, this is the XQ, and I will see that it is falling in the diabetic region. That's why I will predict that, okay, this person can have a diabetic. Okay, this is the kind of general prediction, guys, I'm trying to say. Okay, now you will say that, okay, sir, what is the divide and conquer and what is the thing here? Okay, listen now. See, guys, there is a one intuition and we have one algorithm, which is a SVM. SVM stands for support vector machine, right? So SVM generally we are using for classification, correct? So they are telling that this plane I draw here, right? This plane to classify that, so that all the points which are belong to the diabetic class will be on one side, and all the points which are belong to the non-diabetic class should be on the other side. Correct? So I'm trying to do like this. So we need to draw this decision boundary. This we call it as decision boundary, guys. Right? So the question is that how we can choose this decision boundary? We can use the divide and conquer strategy, guys, right? And how to use divide and conquer strategy to choose this decision boundary, we'll see that, right? So that you will understand whatever the techniques or what are the algorithmic things you're using that are getting extensively used, guys, right? So that's the reason I'm telling these are the core things that you have to know, because you are making the career in this. So ऊपर ऊपर पता चल के कुछ नहीं होगा, guys, again I'm telling. Okay, now listen. So there is a one problem statement which is a convex hull. Convex hull. Convex hull means what? Convex hull, again, guys, if you go into the lead code, we have particularly one problems on the basis of convex hull, right? Which is again divide and conquer strategy. Strategy. Right? And how we are using this convex hull divide and conquer strategy to find out this decision boundary, right? Because, guys, we can draw in this way, even though we can draw in this way, right? We can even draw in this way, right? So which one is the best one? We have to find out that. So for that, I'm using here divide and conquer strategy, correct? So first of all, understand, guys, what is a convex hull? Suppose you have a point like this, and guys, listen to me, because we need to code this convex hull also, right? So fine, because again it's the problem statement, right? So convex hull, again, this is the divide and conquer problem statement. So how and what is convex hull? Convex hull means what? Basically, we are trying to draw a polygon, right? In a convex hull, in a convex hull, basically, we are trying to draw a polygon. We are trying to draw a polygon. And what is how we are drawing the polygon? We have to draw the polygon in a such a way that all the points will be on the polygon or inside the polygon, right? Suppose you have a point like this. So I'm telling that you have to draw a polygon in such a way that all the points are on the polygons or inside the polygon, right? If this is the case, then I can say that it's a convex hull, right? Otherwise, I can say that it's not a convex. For example, guys, suppose you have like this. Let's take the, suppose you have like this, okay, right? And suppose I am telling that you have a point here, also you have a point, and if I draw a distance from this point to this point, it is going outside this polygon. So I can say that this is not a convex hull, not a convex hulls. So what I'm trying to say, guys, we need to draw a polygon in such a way that the either all the points will lie on the polygon or it will lie inside the polygon. If this is the scenario, then I can say that we call it as the convex hull, right? So same thing they are telling that, okay, you have a problem statement now. Now you need to draw a boundary for this one, right? So let's take the example of this one. So what you have to do, guys, just I'm telling the intuition, guys. Again, we are moving towards the DP, so don't worry. This session will be little bit, will take more time, but we have to continue, right? So I'm telling that, okay, these are the points you have. Okay, fine, right? And these are the points, and you have this points, correct? So what I'm trying to say here, okay. So first of all, the first step is, because we need to draw a decision boundary. So first step is what? You need to find out, or you need to draw a polygon in a such a way that all the points will be lie on the polygon or inside the polygon. This is nothing but the convex hull. So what I will do, guys, I will draw this polygon like this. So I'm drawing in such a way that all the points will be lie on the polygon or inside the polygon. right? This is the polygon I draw. Similarly, what I will do is I will draw this polygon, right? These are the polygons, correct? So I'm drawing in this way that okay, right? I'm drawing in this one. This is the polygon one. This is my convex hull one, right? And this is my convex hull two, correct? Simple, guys, simple. I'm making very simple, right? So we are constructing this polygon separately, right? Now we know that this class is belong to the diabetic and this class is belong to the non-diabetic, correct? Simple. Up to here, clear, guys? Now what we need to do, you take one point from this side and you take one point from this side. So you have to take a point in both sides in a such a way that the distance between this hull and this hull should be minimum, right? So what I will consider this point, guys. This is my first point and this is my second point, correct? What I will do, I will draw this line, right? This is what, this is the point from this convex hull 1 and this is the point from this convex hull 2, correct? Now what I'm trying to say, we need to find out any 2 point from this convex hull in such a way that the distance between these two is somewhat minimum, correct? So I got this 2 points, correct? I got this 2 points. Now the question is, because I wanted to draw a decision boundary here, guys, right? So what I did, first I draw the convex hull, I find out this point and this point so that the distance between these two is minimum. Now what I will do, guys, I will bisect this line. What is the meaning of bisect? You are dividing this line into two equal parts, right? This is the two equal parts, right? Right? So guys, this is what, this is the divide and conquer strategy, right? And generally this is the convex hull problem statement, and this convex hull problem statement are nothing but a divide and conquer strategy. And what I did here, simple logic, simple algorithmic logic I use to solve this kind of machine learning problem statement. And this algorithm is nothing but the support vector machine algorithm, guys. Right? Although there are some pros and cons, but the thing is that I'm telling you that whatever the things we are learning, it's not a casual thing, guys, right? That you will take this thing casually because you're making your career in this domain, so you have to know the things, right? So what I'm telling you that we are simply using our algorithmic strategy, right, to find out this decision surface, right? Simple. This is not only this, guys, we have a many application of the divide, and in tomorrow's session whenever we'll code the neural network, you will understand that how we are using DP internally extensively, right, to implement such a kinds of algorithms, right? Fine. Okay, now come to the point, guys. Okay, so what we need to do here, that we need to identify the problem statement first, that whether it is a DP problem statement or not. And we know that we generally have a three ways. First one is that suppose we need to find out the all possibility, that is the first way. Second thing what we need to do, we need to check that is there any sub problem which is overlapping, right? First of all, we'll focus on this two thing because we don't know currently greedy. Once the greedy will come, we'll see. Greedy also has the many machine learning use cases and deep learning use cases, guys. Right? Fine. Now listen. Let me take one simple problem statement, guys, which is a, let's take the climbing staircase. Right? Suppose this is one of the lead code question, climbing staircase. Right? This is the problem statement. And the problem statement is like that you are, suppose I'm telling that you are climbing a staircase. You are climbing a staircase. It takes n steps, right? It takes n steps, correct? And n steps to reach the top. To reach the top. Please understand the problem statement, guys. N steps to reach the top, correct? And each time we can climb, each time we can climb one or two steps. Right? This is the constraint that you have a staircase, right? You need to climb a staircase. You have n steps in that, and each time you can climb either one step or two steps, right? The question is that in how many distinct way, In how many distinct ways can you climb the top? Can you climb the top? Right? This is the problem. See, this is again one of the lead code question, right? And most of the people know that this is the recursive approach. And if they try to submit this code using recursion, the solution is not getting accepted, right? Because they are telling that time limit exit, or they will simply say that, okay, memory is out of, right? So the simple thing is what, guys, we need to solve this question, right? And first of all, understood, guys, is this a recursive question? This is my question for everyone. Is this a recursive question? If this is a recursive question, let me know, guys. Hi, Anna. Yes or no? Okay, fine. Yes, it's a recursive question. Correct. Fine. So let's first of all, those who didn't understood the question, listen, guys. What is a problem statement? Correct. What is a problem statement? Okay. So you have a staircase, guys. You have a staircase. I hope everyone knows staircase, right? Please understand this question is very simple, guys. And you have an n staircase, right? So you are at this position. Let's take that you are at 0th position. So you have to reach the top. Top is nothing but this n, correct? And you have only two options. Either you can take a first steps, or either you can directly take a two steps. You have these two options, correct? Okay. Now they are telling that in how many distinct ways, you can climb the top, right? In how many distinct way you can climb the tops? This is the question. Okay. And suppose they have given the input n denote the number of staircase, right? N equals to 1, n equals to 2, right? N equals to 3, correct? And n equals to 4, right? This is the kind of options they have given to you, correct? So you have a n equals to 1, n equals to 2, n equals to 3, n equals to 4. So this is the input they have given, and you need to find out the how many different ways you can go, correct? Fine. Now listen, guys, simple thing. Okay. First of all, you have a choice here, right? You have a choice here. What is the choice, guys? Right? Either you will take one step, or either you will take two steps. You have a choice like this. Either you will take one step, or either you will take two steps. Now, for example, guys, suppose you have only one staircase, right? N equals to 1. So what will happen? Here is your n, right? And here you are at the 0th position, correct? So if you wanted to reach the top here, obviously you have only one possible way, right? So I'm writing here only one possible way. If you have only one staircase, correct? Fine. Assume that now you have a two staircase like this. One, correct? And this is your top, which is n. And you are at the 0th position. So you have either this one, or either you can directly reach this one. Two, right? So you have this steps that, okay, that either you will go with a 1 1, either you will go with a 1 1, or you can directly go to the 2, right? So what I'm telling is, either you will go first this to this, or this to this to reach this one, or you directly reach out the second one, because you have a choice that either you will climb one step, or either you will climb the two steps. So you have a two options here, correct? You have a two options here. Clear, guys, up to here? Yes or no? Fine. Now listen. Now the question is, what about n equals to 3? Right? So if you have a staircase like this, guys, if you have a staircase like this, can you tell me how many different ways that you can climb if you have a n equals to 3? Yes, answer please, guys. How many different ways you can climb if you have a n equals to 3? Anyone? 2 1 1 1 1 1 2, right? So you have option, guys. You have a either you can climb 1 1 1, or either you can climb 2 comma 1, or either you can coin 1 comma 2, right? These are the possible ways if you're thinking about the staircase is 3. So I'm telling that here there are 3 ways. What about 4, guys? What about 4? If you have a 4, what, how to this one? You have a 2, 2, and how many options you have, guys? Either a C, either you have a 1, 1, 1, 1. This is the one option. Either you have a 1, 1, 2. 1, 1, 2 means what? Either you will climb first step, and then directly second step. Or you can say in this way, 2, first you will climb the 2 steps, then 1, 1, correct? Then you can say that you can climb 1, 2, even 1, 1, correct? Or you can climb 2, 2. So if you observe this one, how many different ways you have? You have a total 5 ways, correct? Just to break down the problem, guys. Okay, how many ways you can get that one, right? So you have a total 5 ways. Okay. Now the question is, guys, okay, I wanted to solve this question, right? I wanted to solve this question. First of all, I'm not directly saying that it's a greedy problem statement, but definitely it's a recursive problem statement. Yes or no? Right? Yes or no, guys? Is this a recursive problem statement? If I'm asking it's a recursive problem statement, the question is why? Why it's a recursive problem statement, guys? Come on, guys. Why it is a recursive? Because we know that. Suppose I have a n staircase, n equals to 5. I know that I have to find out the different ways you can go to the staircase of size 4, plus I have to go that the different ways to staircase of size 3. Correct? Suppose I wanted to climb n equals to 3, means I have a 3 steps in the staircase. Sorry, not 3 staircase. So if you have a 3 steps in the staircase, so I can say that I need to find out the how many ways we can go to the second, and how many ways we can go to the first. Correct? Right? So if you observe this one, this is the similar kind of problem statement, guys, like a nth Fibonacci number. Yes or no? In nth Fibonacci number also, suppose I wanted to find nth Fibonacci number, you need to find out, suppose I wanted to find the fifth Fibonacci number, you need to find out the fourth Fibonacci number, plus we need to find out the third Fibonacci number. Correct? So if you add the fourth and if you add the third, then only we will able to find out the fifth Fibonacci number. Correct? This is the scenario. Correct? So if you see this problem statement is completely analogous to this one, right? And we know that the approach we are discussing here, right? This Fibonacci, it's a recursive approach. So the see again, I'm telling. See, suppose it's sometimes it's a difficult to find out the problem statement is a recursive problem statement or not. So what we'll do, we'll use the reverse engineering. We'll try to find out any problem statement which is analogous to this problem statement, and we'll see that okay, that problem is a recursive problem statement. Then we can say that okay, this can be also recursive problem statement. Correct? Now, so if this is a recursive problem statement, guys, this climbing a staircase, can you tell me the logic for this one? Anyone? That how to code this one? We'll code it, guys. How to code this one? That so either you will choosing is the correct way, right? Okay, fine. So what the first of all thing this I am telling that I have a n equals to suppose let's say 3. So I am telling that what are the different ways to climb whenever the staircase steps are 2, and what are the different ways to climb when the staircase steps are 1. Correct. This is the general logic that we are following here. Okay. So can you tell, guys, okay, how to do this one? Right? Anyone? Yes. Let's take, guys. First, I will use the greedy approach. Greedy approach, right? Greedy plus you can say that somewhat math. Greedy plus maths. Okay, fine. So as we know, guys, as we know that in every step we are taking a two decision, right? So in every steps we are taking two decision. We are taking two decision. Correct? And what is the decision? That you are climbing a one step, we are climbing a one step at a time, or we are climbing a two steps. Climbing a two steps. Right? So you are climbing a one step or you are climbing a two steps. Correct? This is the scenario that every time we need to choose either I am climbing a one step or either I am climbing a two steps. Correct? Now, so guys, if you know that if you have a two options, if you have a two options, right? I know that this is the kind of binary number problem statement that, okay, you have a two option, and I can represent this with the one logic that, okay, you have a two choices for what? N staircase. So I'm telling that 2 power n can be a mathematical solution for this problem statement. For example, I'm telling that, okay, n equals to 1. N equals to 1 means what? Suppose you have only one step in the staircase. So if I'm taking 2 power n means 2 power 1. What's the answer, guys? 2 power 1 answer is a 2. But we know that whenever you have only one staircase, you have only one option. Yes or no? You have only one option here to climb the staircase, correct? But what it is giving? It is giving you the wrong answer. But if I'm writing the same statement in this way, guys, 2 power n minus 1, what do you think? Now, if I'm telling that if I have only one staircase, right, only one steps in the staircase, I can say that 2 power 1 minus 1 is how much? 2 power 0. And 2 power 0 is nothing but 1. So I can say that, okay, if you have a one step in the staircase, you have only one way to go. Okay, let's cross check it for the n equals to 2, guys. So can I write like this? N equals to 2 power minus 1. So n equals to 2 power minus 1 means what, guys? 2 power 1, which is 2. So in case whenever you have a two steps in the staircase, guys, do we have a two ways to climb it? Yes, everyone. If I'm telling that I have a two steps in the staircase, do we have, suppose I know that n equals to 1 means what? We have a one option. If n equals to 2, how many option, guys? N equals to 2 means how many? 2. If n equals to 3, how many option, guys? How many different ways we can climb? Obviously 3. Correct. So you just cross check it. Like, we are not using any DP here, guys. We are just using a simple maths. Okay, the logic to find out this one. So I'm telling that, okay, n equals to 3. If I'm taking n equals to 3, how many different ways? 4 ways, correct? So I'm writing here 2 power 3 minus 1, right? Which is a 2 power 2. And 2 power 2 is nothing but what? 4. Correct? So fine, this logic is working here that, okay, that we will able to find out this one. This is the one logic. Or we already know, guys, that, okay, if it is this is the problem statement which is analogous to the Fibonacci series, then we can directly say that, okay, fine, we can easily code it. Okay, fine. So suppose, guys, let's take, we need to code this recursive problem statement. So can you tell, guys, what is the anchor step here? This is the question for everyone. Let me know, guys, what is the anchor step for this problem statement? Anyone? Yes. N equals to 1, 1. Okay. Any other? Okay. So please help me, guys, to code. N is less than or equals to 2. Okay. Okay. Any other way? Suppose, guys, let's start with a simple problem statement, right? Right. Suppose you have a n equals to 1. N equals to 1 means what? Only you have a one step in a staircase. So this is the scenario that you need to reach a top and you are standing at this 0th position. So you know that you have only one way to do it, right? Let's take, guys, suppose you have n equals to 2. So you have to climb this one, correct? You have to climb this one. So what I can say that you have either you will go with the one this way, right? Or you can directly go with the this way. You have a two option. Correct. So n equals to 1 and you have n equals to 2. So guys, can I say that the my anchor step will be what? If if my n equals to 1 or n equals to 2. If this is the kind of scenario, I will directly return n. Yes or no? Simple, guys. If I'm telling that, okay, I have only one staircase, one step in the staircase, or I have only two steps in the staircase. If there is only one step in the staircase, I will directly return 1. If there are two steps in the staircase, I will directly return 2. So let me code it, guys. Suppose I'm writing here def climbing staircase. So guys, first we'll try to write a recursive approach and then we'll use the DP recursive. So I'm writing here, suppose n value. Okay, fine. And I'm writing here base case that if n equals to 0, sorry, n equals to 1 and n equals to 2. If this is the scenario, I will simply say that return and else, guys. Now, what is the recursive step? Simple, guys. How to find out the recursive step for this one? See, suppose I have a 3, right? Means why I have a 3 steps in the staircase. I got that this logic that okay, if you have 3 staircase, I can say that how many ways you can climb a staircase with a size 2 and how many ways you can climb a staircase of a size 1. So you just add these two things that you will get it. Correct? Similarly, guys, suppose I am telling that you know one thing, n equals to 5. N equals to 5. How many distinct ways are there to climb the staircase, guys, if you have n equals to 5? Yes, anyone? If I have a n equals to 5, how many different ways? You have a total 16. Is it correct, guys? No. How will you get 16? What about n equals to 4? If you have n equals to 4, how many distinct ways you have, guys, to climb the staircase? N equals to 4 means you have a 5, right? So if you have a n equals to 4, how many distinct ways you can climb? 5. Now, guys, I am telling that you break this problem. You wanted to climb a 4 steps. You can make it that climbing a 3 steps and you make it that climbing a 2 steps. So how many ways we can climb a 3 steps staircase, guys? You have a 3 ways, right? And how many ways you can climb a staircase of step 2? You can climb in 2 ways. So you can add this 3 plus 2 is what? 5. Simple. So same logic I'm trying to implement here, guys. So what I will do here, I will write here return. I'm writing here climbing a staircase. I'm writing climbing staircase of n minus 1 plus, again I am writing here climbing a staircase of n minus 2. Correct? So simple thing, guys. Okay, see. Now what I need to do, let me call it, guys. First of all, check, is it a correct approach? I'm asking, guys, again, is it a correct approach? If I'm calling here, suppose 2, what it has to return me? It has to return me true. But it is a correct approach. Let me know. That will get the answer in this way. Okay, fine. Now what they are telling here? Recursion error. Maximum recursion depth is getting increased. Okay. So what I need to change in this code? Instead of and, you should use or. Correct. So what I will do here? Or. Right. Now if I run this one, I will get the answer too. Yes or no? Let's check for the other guys. Suppose I have a 4. I'm getting here 5. Correct. Now you observe this one. Can you tell me, guys? Can you tell me what is the time complexity of this code? Because this problem is similar to the Fibonacci series problem. So if you tell me the time complexity, if you calculate the time complexity for this one is what? Time complexity of this one is 2 power n, definitely same like a Fibonacci, right? So which is the exponential time, correct? And space complexity will be again n. Okay. Now guys, we understood that okay, this is the recursive problem statement. First of all, this is the recursive problem statement. Now the second thing is what? Now I'm telling that if it is a recursive problem statement, now second thing, find out is there any overlapping sub problem present in this case? Is there any overlapping sub problem, guys? Let's take the example. Suppose I am taking here value f of 5. Means what? There are 5 steps in the staircase. So I can say that this problem will become f of 4. I can say that this problem will become f of 3. Correct? Now if you talk about this one, this will become f of 3. Right? And this will become f of 2. Correct? Right? If you observe this one now, this is also f of 3 and this is also f of 3. I can say that this is the overlapping sub problem. Yes or no? Yes, correct. Now, wherever there is overlapping sub problem, guys, we can use DP. Correct. Okay. Now understand, guys, because we need to code this thing using DP. Correct. So first of all, how to code it? Okay. So listen, guys, first of all, I will tell you the approach and you code it. and tell me the solution, right? Because it's not like that only I'm coding, right? So listen, what I will do, I know that one thing because we need to reduce the number of function calls. So what I will do, first step is what? Whatever the result I'm getting here, I'm trying to store it. Okay. So let's take a simple list, guys, here. Let's take a simple list. Okay. You take the list of size n because you have to store the n values. Okay. Suppose, guys, listen. Suppose I'm writing f of 5. Right. So, guys, how many values you require? You required f of 4, right? F of 3, right? You required f of 2, correct? You required f of 1. Correct? These are the values you want to find out the f of 5, correct? So, guys, what our strategy is, what we wanted to store these values, right? So that you don't need to call this function again. So whatever the result we are getting from the f of 3, I'm storing in this list so that I can reuse it. So you don't need to do the recomputation here, correct? So what I will take one list whose name is called, suppose, dp, right? And initially we know, guys, we know base case when n equals to 1 and when n equals to 2. Correct? What will happen? So what I will do, guys, I will start from here. Okay, when n equals to 1, I'm keeping here answer 1. If n equals to 2, I'm keeping here answer 2. This value we need to initialize because these are the base steps, right? So I'm initializing here 1, I'm initializing here 2. Correct. Now, what I have to do, guys, suppose I have n equals to 3. I have to find n equals to 3. So, guys, what you will do? You know that you need to call f of 1 and you need to call here f of 2. Correct? And we already know what is the value of f of 1 is already stored in the list, which is 1, and what is the value of f of 2 which is already present in the list, which is 2. So what I will do, 1 plus 2 is 3. So this 3 also I will store it inside the list. Correct? Now somebody asked me what is the value of n equals to 4. So I can say that, okay, you have a f of 3, right? And you have a f of 2. And already in this list, I have the value of f of 2 and I have the value of f of 3. I can directly store this, guys. So 2 plus 3 is what? 5. So I can relate here. This is nothing but what? Number of steps in the staircase and different. This is what? How many distinct ways you can climb the staircase. Correct? This is the simple solution, guys. What is happening now? Next time, once you calculate the value of f of 3 here, next time whenever the f of 3 will come, I will directly simply put the value. For example, suppose I have a f of 5. F of 5 equals. I am telling here f of 4. I am writing here suppose f of 3. Correct? Correct. Here also I am writing f of 3. And here also I am writing f of 2. Correct. Now, guys, suppose I came here, I calculated the value for this f of 3 and f of 3 value is 3. I already stored this value in one of the lists. Next time what happen? I don't need to store this value. I will directly take this value from this array or this list. I will directly say that, okay, the value of this one is 3. So I'm not calling this function again. That is the beauty of DP, guys. Right? Correct? I'm not calling this function again because in the case of recursion, the number of function call will decide the time complexity of the recursion. Okay. So guys, first of all, what we need to do to write down the solution for this one. First of all, let's take the example. First of all, what we need to do. Right. So I'm telling you the approach, guys. Please try to code. Right. So I'm telling you the approach. Listen, first you initialize. Right. Because to find out anything that we need to initialize. So I'm initializing. Initializing means what? You find out the anchor step. See, guys, after writing this in DP, you can submit this question on lead code, right? And you can use this all approaches. You can use all these approaches wherever you require a recursion, right? Fine. Okay, what's it out? In case of n equals to 4, we have to add n equals to 2, n equals, correct? Correct. Fine. So initializing the anchor step. Second step is what, guys? You create one list whose name suppose DP. I'm creating one list whose name is what? DP. Correct? Now, so what is there in the list, guys? Suppose I'm telling that list, this is the DP list. Initially, what is there? In the list, initially you have the value of n equals to 1 and n equals to 2, because we know that n equals to 1 means how many distinct ways you can climb? 1. If n equals to 2 means how many distinct ways you can climb? 2. Okay. These are the value initially present in this list. Okay. Now next time what happened, guys? You already have this one or two values. Now simply what we need to do is we need to call the function, right? So I know one thing that, okay, I know one thing that once we have a list created, right? So let's take the same example. In this list, I have a list like this. Listen, guys, listen. Otherwise, you will again get confused. I'm writing here. This is the first n size, n equals to 1, and you have a n equals to 2. These are the values, suppose you have. So I'm telling that if you have n equals to 1, you have 1, and n equals to 2, you have a 2. Now, guys, if anybody given, suppose I need to find out the value of f of 5. Okay. Now, guys, you know one thing that, okay, I need to go f of 3 and I need to go f of 4, like this, correct? Now here I know how to get f of 3. We just need to add this one and this one, correct? Here you will get f of 3 and you need to get here f of 2, correct? So guys, if you observe this one, you just need to iterate this list, right? If I iterate this list, I will directly get a solution, correct? So what I'm trying to say, let's think, guys, how to code first, because I already explained. I'm telling that first, you initialize these things, right? You initializing the anchor steps, you create a one list which is name is DP, and this initialization you do it in this DP list, correct? And guys, one more thing that we need to define we need to define the size of list, right? This DP list. Okay. And then the next thing is what we need to iterate this. These are the only three steps we required, guys. Okay. So can you tell guys how to code this one? No need dictionary. No need, guys, dictionary. You can use, but dictionary approach will use in memoization, right? This is the tabulation method. Yes, anyone? Okay. So guys, I will write the half code for you. Just listen. So what I will do, I will declare here def climbing climbing staircase DP. Correct? And I'm writing here n. Correct? So initially I will define it, guys. If n equals to 1 or n equals to 2. This is the case you simply written n. Okay. This is the base case you need to define. Correct? Now what I will do, guys, I will create one DP name list. Okay, so let me create here. Suppose let me create here one, guys, DP. This is my empty list. Okay, fine. So initially, what should I do, guys? I need to initialize this two thing in that one. Correct. So do I need to specify the size of this list, DP list? Because I need to write like this, guys, DP of, because we know that list index will start with a 0. So I'm writing DP of 0 means what here? What is the meaning of DP of 0, guys, here? DP of 0 means it is representing the index whenever you have the one step in the staircase. Then in that case, what is the value? 1. I'm writing here DP of 2. What's the answer? 2. Correct. My question is, guys, okay, fine up to here. My question is, do I need to specify the size of this list? Question, guys, do I need to specify the size of this list? No. Yes, no, yes, no. Anyone? Okay. So how to specify size, Ujjwal, if you wanted to specify? Because initially only we need to define, guys, what the size. It depends on number of times you are calling the function, right? Yes. Okay, some people are saying we need to define, some people are saying we don't need to define. Okay. Anybody? Okay, let's take, suppose we are defining the size. Okay. Let's assume that we are defining the size. Okay. So how to define, guys? Tell me how to define the size for this list. Means how many list block I need to create. Suppose I wanted to create this list. Come on, Python guys. I'm telling that how many blocks we need to create in the list. Suppose I wanted to define the size of this one. Anyone? Okay. What n will define, guys? N will define the number of steps in the staircase. Okay. The question is, guys, how many n plus 1? Okay. Anyone? Other answer? So can you tell me, guys, how should I write this one? Can I write? How should I? Because, guys, remaining things are very simple. Remaining things are very simple. I already have the first steps value, two steps value. I will simply do iteration for I in a range of, correct. I will simply do the iteration because I already have this one and this one. Right. This is the 0th one. This is the first one. So I am directly starting from a 2. Correct. 2 to where? Up to the length of this DP. Right. And first of all, tell me, guys, the size, then I will write here. Right. Then finally I will write DP of I equals to DP of I minus 1 plus DP of I minus 2. Right. And that's it. And then finally I will return DP of N. Correct. But guys, my question is, okay, fine. Remaining all things are sorted. Remaining all things are sorted. But the thing is that if I wanted to specify year size, how to specify, guys? Because I wanted to create a table like this. Right? Because this is nothing but, this list is nothing but the table for it. And this method, we generally call it as the tabulation method. Right? So I'm storing the first value, I'm storing the second value. Next time I need to store the third value. Right? So you can tell us, sir, without specifying the size, we can use the append every time. Whenever we are adding this first one and second one, we can use the append. Yes or no? That approach also we can use. Right? Right? Fine. Okay. Many of the people are getting none, star. Okay. See, guys, instead of none, you initialize it with a 0. So what I will do here, I will write a simple thing. Take the list whose all elements are 0 into what is, guys? Because we don't know the value of n. Whatever the value of n is there, I need to create that side list. Fine. And similarly, that's it. What it will do? Suppose I'm passing the n size as 5. Right? So I'm creating the array or I'm creating the list of this size. Correct? So what will happen now? I will write here what? I have to go up to n plus 1. Right? Let me write down, guys. Now, if I define the size of this list here, okay, if I define the size of list here, and I know the first value and I know the second value of this one, right? So this is the 0th one and this is the first one. Now next time, definitely I need to iterate from 2, right? Listen, guys, listen. I'm telling that you know these two values, correct? Now what you need to do, you need to find out this value, means I will directly start from this here, right? So if I start from here, okay, any I value is 2, what it is doing, dp of 2 equals to dp of 1 plus dp of 0, correct? And dp of 1 and dp of 0, I already have a value, so I'm telling that dp of I equals to dp of I minus 1 plus dp of I minus 2, correct? dp of I minus 1 plus dp of I minus 2. So what I can say that dp of 2, suppose I wanted to find out. dp of 2, suppose I wanted to find out. How to get that one? Correct, correct. You can reduce, guys, n minus 1, correct, fine. So I'm telling that, okay, this is what dp of n minus 1 is 1 plus dp of 0, right? So if you see here, guys, if you see here, guys, not at all, not at all. I'm calling a same function multiple times. I'm just iterating only one loop, right? And if I pass here, suppose let me pass the value. Suppose I'm passing here one value. Let me pass here one value. Correct. Uh, let's take. See guys, loop you can iterate in your own way, and if you don't want it to initialize, you can append it also, no issue. So I'm writing here 4. What's the value you are getting here? Climbing staircase DP. Whenever I'm passing 4, I'm getting what value here? 2. Why guys? Is 2 is the correct answer? Is 2 is the correct answer? So what should I need to write? I need to write here 1. Correct. Fine. Okay. Now for a 4, you have a 8 option, guys. Huh? You have a 4, you have a 5, or you have a 8 option. So think, guys, think here. I have written the code here. We required an answer 5. But this is the approach. But tell me now, what should I change in this one? Because if you are able to do the question in this way, you know that this program is taking only order of n time. Right? Although we know that we required extra space, but currently we are focusing on the time. So it is taking order of n time only. Correct? So what should I change in this code? So up to n plus 1, do I need to change n? Any other answer, guys? Think and let me know. Yes, anyone? Okay. So let me know the answer, guys. Let me change it to n. Oh, sorry. Let me change it to n. What's the answer, guys? I'm getting 0. Huh. So what should I change now? Come on, guys. N plus 1 to n I have changed. Now what should I change? Here also you are telling. Okay, here also I will change. See here, what you are getting? List index out of range. You are familiar of this error, guys? Huh. So what should I change here? Come on, guys. Is there any mistake in this code? I'm asking. See, this is the first question. That's why I'm tracing and doing everything. Okay. So what should I do here? Why DP of 1, DP of 2? This one. LEN of DP kar. Okay, fine. Let me do LEN of DP. Hmm. It's still showing out of index range. Hmm. Anyone apart from this? Okay. Okay, fine. This is okay. But why DP of 1? We need to initialize DP of 1, DP of 2 like this. Guys. Okay, fine. Good, good, good. Sujata. Okay, is there any other way that you can do? Let me know. DP minus 2 करूं. LEN of DP minus 2. Okay, let me take DP minus 2. Hmm. DP minus 2. You are getting again index error. Come on, guys. Any other answer I'm expecting from you? But at least you understood the approach. Now think, guys, how to get the correct answer from this one, because this is the approach. And if you observe this one, this loop is iterating up to n. And if you're trying to find out the time complexity of this question, is nothing but the order of n only, right? It is not order of 2 power n, right? Problem in a base case. See guys, if you're getting a problem in a base case means you will get a recursive error, right? You will not get an index error. Yes, come on. Anybody? What should This is the correct one, Sujata. This is the correct one. See guys, this answer is the correct one. You will get the exact answer. But guys, what should I change in this code? What's the wrong in this code? I'm asking. You understood now? So what is the wrong in this code? I'm asking. Is sorry guys, this is also giving the incorrect answer because we have to get the answer 5 na. So what should we change? Come on. Because correct, one step one way, two steps two way. Huh. Okay, got it. One step one away, two step two. But what should I change in this? I will make here one and I will make here two. Fine. One step one away, two step. But guys, we know that the list will start with a zero now. Huh? We know one thing that the list will start with a zero. And here also I'm getting a wrong answer. Come on, guys. Instead of two, it should be one. Where? In a range. Okay. Let me take here. Instead of two, it should be one. But guys, why will I iterate from one? Because already in the first position, we have a n equals to 1 value. In the second position, you have a n equals to 2 value, right? So here, if I keep here 1, I'm getting the answer 0. See guys, again I'm telling, don't tell the answer blindly. है ना? If you wanted to get exact answer, mean please press it. Put 3 there in the place of 2. Where 3? In a loop. Okay, so let me put it 3. Fine. So you're getting the answer 5. Okay. Now the question is, guys, okay, fine, you got answer, fine. But guys, how you will identify this one? Suppose if you got that kind of scenario that where you are writing a code, but you are getting the answer incorrectly, correct? Where you are getting the answer incorrectly, correct? So how you will find out these things, right? So the best way is, guys, to get a correct answer is what? Please trace it, right? While tracing only, you will get the many answers here, correct? Fine. And one more thing, guys, one more thing. This is the first question of a DP, right? So don't worry about that, okay, sir, how you are able to write and it's difficult to understand one thing. See, guys, once you are habituated of solving this kind of question, first of all, learn how to identify it's a DP question, right? Because if you are taking a complex problem, sometimes it's difficult to identify whether it's a recursive or not, right? Forget about the DP even, correct? Fine. Understood, guys? Yes or no? This is the simple question. And I will give you one similar kind of question, guys. Please try that one also. Similar kind of question, you know. Minimum cost of climbing stairs. Minimum cost of climbing stair. Similar kind of question, guys. Right? Minimum cost of climbing care. It is also the similar kind of question. Yeah, guys, you can use no issue. But if you take DP, if you take n plus 1, ultimately the loop is going up to n only, na, guys. So the time complexity will be n only. So my suggestion is what, guys, please try this question number 746. Right? You try this 746, right? 746 and submit it. Guys, similar approach you can follow. We'll continue this session tomorrow also, guys, right? Tomorrow we'll see some of the complex questions, right? Cutting rod questions, we'll take knapsack, and then we'll code a neural network. Again, I'm telling, guys, I just wanted to talk a few things with you, that please understand the concept, grab the things, then only you will able to code it, all these things. And simply, guys, you are in the domain where we require the good problem solving skill. Again, I'm telling, it's not like that we required no coding. There will be nothing kind of that, guys. You go into the industry, you will realize that it's not about data science, is not about the copy pasting the things, right? You have to apply the logic. Even though if you are doing the analysis also, you have to think much, guys, right? And if you are a fresher, definitely you have a good opportunity to crack the product base, right? And probably in that case, you require this kind of knowledge only, right? There is no alternative other than this. You think that simply knowing the machine learning and deep learning knowledge you will crack the product base, then definitely you are in the wrong path. Again, I'm telling, right? So you have to know the things. And even though, guys, each and every technique that we are going to use, right? I will tell you, the where exactly we are using this algorithmic techniques and all the data structures, right? Let's take the example, guys. Let's take the example. Suppose we have one algorithms in the machine learning, which is a KNN classifier, right? Let's take this example, right? And if you observe the syntax for the KNN, whenever you are importing the KNN classifier, you have option called algorithm, right? Right? Algorithm is auto. You go downside, guys. You go downside. Algorithm. So here you have a multiple algorithm. You have a ball tree. If you have a KD tree, you have a brute, you have auto. What is this, guys? This is nothing but the data structure that you are extensively using in the particular algorithm. Let's talk about the KD. KD means k-dimensional binary tree, right? Generally, we are using this algorithm to find out the nearest neighbor, right? And we need to optimize the time for finding out the nearest neighbor. That's why we are using different sorts of algorithm. It's not like that, guys. You simply do the hyperparameter tuning and you will get what is the best parameter for this one. If you are going in that way, then what's the use, guys? Even the kid can do these things, right? So similarly, you have to know this thing, guys, why we are doing this one and how this KD tree algorithm is helping you to find out the nearest neighbor in the less time. Again, it depends on the what kind of data, how much size of a data you have. But my main intention to tell you what, guys, whatever the things we are learning, whether it is a data structures and algorithm, these are the core ideas of any technologies, right? So that's the reason I'm telling always focus on the core part, right? Advanced things people will ask only when your foundation is good, right? If your foundation is not good, nobody is going to ask you the advanced things, right? So remember one thing, guys, always focus on the foundations, right? And as a fresher, definitely they will focus more on the foundations, right? Rather than the advanced thing. For doing the advanced thing, they have more experienced people, guys, in the industry, right? So again, I'm telling guys, whenever you are learning this kind of cutting edge technology, please try to go with the foundation, learn the things in a proper way, then only the things will be easy for you, right? So we will take this session tomorrow also, guys. We'll try to solve one of the complex question and definitely we'll code the neural network, right? And we know that, guys, in particularly in this our course, we are trying to code each and every algorithm from the scratch. And nowadays that kind of questions only they are asking, right? So please focus on the things, okay? And one more thing, guys, we just wanted to announce one thing that we are going to start a batch for the full stack data science, right? And this is the detail if you wanted to join and all these things. Initial days we have a demo, and if you wanted to join these things, please follow these things. Correct? Fine. Apart from that, guys, we'll take few more complex question in the tomorrow's session and we'll code the neural net. We'll continue these sessions. Up to that, you will get the good idea or good grip on the DP, right? And if you have any kind of doubt, guys, please reach out. Whatever the things I have explained to you, please understand. And the content and the notes I will share, guys, with you. So don't worry. But please follow the approach, then only the things will be easy for you. Correct? Fine. Is that okay, guys? I hope everyone understood. Yes or no? Very simple approach of the DP. Yes or no, guys? Please speak. Fine. Easy, na guys. So because we are doing the easy question, right? So we'll do some tomorrow complex questions and then we'll do. Yeah, guys, we'll upload the notes. No worries. Don't worry about the notes. I will upload. But grab the thing, guys, because this will be very beneficial for you. Correct? Fine. We'll let you know, guys. I will update on the group. है ना? Fine. Yes, guys, let me know. Any doubt? Yeah, no problem, guys. We have tomorrow session also on the same timing, guys. We'll meet. Okay, guys, fine then. We'll meet tomorrow also. Thank you so much. Correct? Fine. Fine. Okay, guys, bye bye. Fine. Thank you. Please, guys, if you have any kind of doubt, please reach out, right? I don't have any issue, right? Right. Fine. Thank you so much. Bye bye.